Good afternoon, everyone. This is Matthew Legad coming to you live from UNESCO in Paris. Welcome to the first webinar that UNESCO-IHP is organizing in the context of its activities for the MedPartnership project. The title of today's event is The Coastal Zone Where Groundwater Meets the Sea. And we're going to be talking today about the activities that UNESCO-IHP is undertaking on coastal aquifers and groundwater for the MedPartnership. We're going to be discussing specifically the work that will be undertaken in the coming year on coastal aquifer supplement to the TDA Med, and also about the activities that will feed into this, including some of our pilot projects. I wanted to thank all of you for joining us today and for your patience with the technical aspects of the meeting. If you have problems during the event, we have a chat feature that's available in the webinar software, so please try to send your messages that way, and also for the discussions we'll have, we'll be able to connect to each other via that method as well. Je voulais aussi souhaiter la bienvenue à nos collègues francophones et de vous informer que la réunion se tiendra en anglais, mais pendant la réunion, vous pouvez nous envoyer des chats en français et bien évidemment, on va essayer de répondre à vos questions pendant les discussions et pendant les présentations si nécessaire. I wanted just to go over the agenda for today's webinar. We're going to set the stage and explain why coastal aquifers and groundwater are important to the Mediterranean region, and also talk a little bit about the interactions they have with the marine environment. Next, we're going to have a presentation by our colleague Andrea Merla, and who's a hydrogeologist and will be leading this work. And we'll also have an intervention by our international water law expert, Raya Stefan. The third point of the presentation, we look at 6 pilot projects, projects that are either implemented directly by UNESCO or projects to which UNESCO is contributing expertise on groundwater and coastal aquifers. Next, I'll give a brief presentation about a platform we've developed to share project knowledge. It's an interactive website where we can exchange information, reports, maps, etc. And then finally, Andrea will take the floor again at the end to talk about the next steps for the TDA supplement and give his view on conclusions from today's discussions. So we'll have discussions throughout the webinar. I'll let you know when we open the floor for your questions. Okay, with that, I'd like to give a brief overview of some of our work in the region on coastal aquifers and groundwater. Here we have an overview map of the participating countries in the MedPartnership, and specifically the coastal aquifers that we studied in the context of the IHP activity. So these are not all of the coastal aquifers in the region, but these are the ones that we undertook more detailed characterizations and studies of. Why are coastal aquifers and groundwater important to consider? These are essential to human livelihoods in terms of drinking water, irrigation, tourism, and industry. You saw on the previous map the location of these coastal aquifers. We note that the groundwater in the southeastern European countries are more used for drinking water, whereas in the more arid regions of the Mediterranean, people relied more heavily on these resources for agriculture activities. And so these resources are essential to human livelihoods in the region, but at the same time, they are also essential to the ecosystem health in the region in terms of supplying freshwater inputs to the Mediterranean Sea. This is important because the Mediterranean, as you know, is a largely closed system with limited inputs from the Atlantic and the Black Seas. So really, groundwater is providing about 25% of the freshwater inputs to the sea. This is important to the water balance and to the quality of the water, and also to maintaining these habitats for biodiversity and also for fish nurseries. So this is another reason why these are important to be considered in our work. In terms of the interaction between groundwater and the marine environment, here we have a cross-section of a typical coastal zone. And this does not take into account any kind of human activity. So we see that there's a natural mixing zone between the fresh water discharging from the coastal aquifers into the sea, and also the sea's impact on the mixing zone, the interface between these two water sources. So this is without human interactions. And then once we take into account the effect of human activities, we can see that there are some things going on here. For example, we've got lowering water tables from pumping to the wells located along the coast. We have the resulting saltwater increasing from the lowering water tables. We also have exchange of pollutants. We have groundwater that's possibly contaminated by pesticides, fertilizers, or wastewater that are introducing these pollutants into the sea. So there's not only exchange of fresh, clean water from these coastal aquifers, there's also a possible introduction of pollutants to the sea. So for these reasons, UNESCO-IHP was asked to bring its expertise in coastal aquifers and groundwater to the MedPartnership. And our two main objectives for this work are to reverse the trends in extraction and quality degradation to these resources, and also then to fill the knowledge gaps on coastal aquifers that exist in the region. The work is divided into 4 main lines of action. I won't go into these in depth, but the first one, coastal aquifer risk and uncertainty, was the component in which we studied in detail the coastal aquifers that were identified to us as the most important ones by the countries. And then we also undertook some work to develop tools to help with management decisions, these vulnerability maps, which we'll talk about later during the pilot project section of the meeting. The second component is about regional actions for coastal aquifers, and this is some of our activities that we've, pilot projects to which we've contributed that are undertaken by our colleagues at TopRock and GWP Med in the context of integrated coastal zone management and integrated water resources management. We also have an activity here on groundwater dependent ecosystems. Next, there's a major portion of our work that's focused on developing recommendations for the policy, legal, and institutional aspects of coastal aquifer management. And finally, there's an activity looking at how we can use spatial imagery to help create the management tools for water managers, including for management of coastal aquifers. So basically, our work is centered around answering a number of questions about coastal aquifers in the Mediterranean. First of all, locating them, trying to determine where the major aquifers are located, what is the amount of resources that are available in them, and also the quality of the resources in these aquifers. Also looking at the possibility of identifying locations in the sea where we're, and then my colleague Raif Stefan will complement that with some information on the policy and legal platform, and I will give you the floor so that you can control the presentation.
Very good.
Okay. Okay, Andrea. Yes, I can see you. And let me activate your video too, so that people can see you when you're talking, please.
Okay, but it not really important.
No. Okay. Well. Okay. Well, all right. Well,
okay.
Let's see. Okay.
So, good afternoon, everybody, and I see many friends among the attendees. So, well, welcome and thanks for joining us this afternoon. I will be quick and concentrate more on the process we are following in the work that is being undertaken on coastal aquifers within MedPartnership. And I thank Matthew for the introduction and set the basis for my presentation. The objective here is of the groundwater component of MedPartnership was to integrate coastal aquifers within the transboundary diagnostic analysis of the Mediterranean, which means integrating consideration of groundwater and coastal aquifer in a large marine ecosystem project. And this is the very innovative aspect of all of this, because while coastal aquifers are well known, there is a lot of science and technology on them, but this is the first time that coastal aquifers are considered under the perspective of marine protection. And I think this is an important contribution that MedPartnership is making to the GF International Waters Focal Area, but also beyond that to all those involved in marine protection. We are making the point, making the case that in order to protect coastal marine waters and the quality and the biodiversity in marine environment, you need to consider not just land-based sources of pollution, but also coastal management, and in that include consideration of coastal aquifers. So this is the thing we want to, the case we want to make, and what we want to demonstrate. I'm trying to move to the next slide, but with no success.
Let me see.
No, they are my arrows that don't work, Matthew. So
can you try to control with the arrow, the button on the screen just above your slide? There's a button. There are buttons for controlling.
In the upper left.
Just above your slide, there are 2 arrow buttons with, and also in between there's the slide number, so you can control.
Thank you. Sorry for that. So this is a slide that some of you know very well, but it shows the context. Maybe for some of the participants is new. The context within which we are acting of a very long-term initiative of the GF in the Mediterranean, which started in the 90s. The first foundational phase ended in 2005 with the transboundary diagnostic analysis and the strategics on biodiversity and land-based sources of marine pollution, which were endorsed by the countries and by the parties to the Barcelona Convention. As a follow-up of that, after about 5 years of preparation, MedPartnership started, which is a very large initiative involving many partners and funding agencies and donors. There has an investment arm with specific projects of the World Bank and others, and a regional part, which is led by UNEP in Athens, and within which we are acting. And as you can see, within this regional component, which has a number of objectives, one of the objectives is to promote the new approaches, among them linkages with coastal aquifers, IHPZN, and IWRM. And this is where we are, and this is what we are going to talk about. What has been done so far, we expect to produce, and what is the process we're going to adopt. The TDA in 2005 produced a very useful documentation, which served as the science and the basis of decision making for taking action to prevent further degradation of the marine environment and of the coast. So hotspots, habitats, and so on. These are some of the documentation produced by this effort, and there is a lot on it. But in this transboundary diagnostic analysis, many aspects of the environment were taken into consideration, but not groundwater, as I said. So this is the innovative part of the whole thing, to to integrate consideration of this very important component, as Matthew before explained. The work will produce a number of outputs. And first of all, as always with groundwater and aquifers, we have a problem of make this resource visible. Nobody sees aquifers, nobody sees groundwater. When it comes to the surface, it becomes surface water, so it's pretty difficult. And so we need to characterize this resource, make it visible by trying to define the location, the boundaries, the thickness in 3 dimensions, of course, because we are dealing with the subsurface, and characterize the current status in terms of quality, quantity, uses, the legal aspects which are related to the use of groundwater, on which Raya will later on tell you something about. So the first output will be a characterization of these various aquifers, which will also include a very, we hope, very useful web-based information system where all coastal aquifers will be mapped and information will be provided on each. And this will be open to the public, I hope, very soon, if it's not already open, I'm not sure. And it's a contribution to the Mediterranean community because it will be a kind of a living database that will evolve in time. So this is a part of characterization. This is the first obligatory step. Whenever you deal with groundwater, you have to make it visible. Visible to the users and visible to administrators and decision makers. We will have another product which is now being prepared and not finalized yet, specific on the wetlands. There are a number of wetlands around the Mediterranean coast, along the Mediterranean coast, everywhere. And the number of these humid zones, wetlands, coastal lagoons are totally or in part groundwater dependent. And this is what we want to highlight and make visible, because this has to do a lot to do with biodiversity in the sea. Many times these humid zones, wetlands, and coastal lagoons represent refuge for fish or spawning grounds, breeding grounds, and so the role of groundwater in sustaining this ecosystem has to be known and somewhat protected. So this will be a second component. Then we will have, and we have already quite advanced in this, a number of, I think 6, if I am correct, pilot demonstrations on specific issues around the Mediterranean, which are shown in this line on the stars, the yellow stars. We have one demonstration. I think we will have a short presentation from Viviana Rey later on, who did the work in Morocco on the use of hydrogeochemistry, which is a rather simple technique in the management of coastal aquifers. Then we will have, we have had 3 important pilots on vulnerability mapping. The concept of vulnerability, maybe we will get back on it a little bit later on. It's very important for management purposes. And there are various ways to define vulnerability and map it. And so we have here 2 examples in Croatia and 1 example in Tunisia. We'll talk about later on. And this is a pilot demonstration which will have, be very relevant for our conclusions. And then we have another pilot which is in a transboundary area in between Albania and Montenegro on integrating coastal zone management methodology with integrated water resources management and coastal aquifers or groundwater management in coastal areas. So an attempt to come up with a plan for the coastal zone of that which integrates all three aspects. And that also will also be done in Algeria and in Regalia. So these pilot demonstrations are intended to provide the opportunity to test techniques, go into more detail in some coastal aquifer aspects, and propose possible solutions, test possible solutions in our effort to introduce better management of this resource. So these activities that I have described and the output we will produce will then help us to come to some conclusions. The first of all will be to integrate the transboundary diagnostic analysis that was done in 2005 for the whole of the Mediterranean Sea without consideration of coastal aquifers, integrate consideration of coastal aquifers through what we call a TDA supplement. Let's say a document that will be based on the TDA, be based on the SEALME, on the identified major transboundary concerns, and also include consideration of interaction with groundwater. But we shall touch on this later on. So the TDA supplement will be a key final conclusion we will reach. And this will not only be on a geological, hydrogeological, environmental basis, but also, of course, from the legal policy institutional aspect, and Raya will tell you something about it. This will be part of the diagnostic analysis, also the policy implications, the present legal setting and might exist, and modification that might be required. Then we will try to move a little bit further, and having made the case that hopefully in an effective manner, that coastal aquifers need to be considered whenever we deal with a marine ecosystem. We will try to bring this case to the parties of the Barcelona Convention and provide a series of recommendations on how to maybe complement the Untitled protocol with the issues related to coastal aquifer management. And this, of course, is a key outcome we expect to achieve through our work, because it would provide sustainability to this effort. It will not be just a test done once as part of a partnership, but become a patrimony of the contracting parties of the Barcelona Convention. And finally, the third outcome we hope to achieve is to be able to provide some concrete recommendations for actions to be taken within the context of the strategic action programs, of the national action programs, or the plans of the countries, in order to improve their ability to manage the coastal zone and its water resources. Of course, I don't see any hands here, so I suppose everything is clear so far. Now, an example of a very simple example of how we are going to proceed in this supplement of the TDA. This table shows in the first column the major concerns perceived in the Mediterranean Sea. Among them, for example, here, the decline of biodiversity. everybody agrees that this is a major issue in the Mediterranean. And there is the TDA provides a description of the many causes that brought to this degradation of the biodiversity, including, of course, a lot of emphasis on fishing and fishing piers, but also pollution from land-based sources and loss of habitat. And the impact, based on this analysis done through back in 2005, conclusions were reached on a few major transboundary concern, what we call transboundary concern, which means by transboundary, we mean that it's concern that required action from more than one country, a collective effort from the countries in order to be solved. And certainly a major one is land-based pollution, which has many forms, and as you may know, maybe point source, non-point source, nutrient enrichment, and so on. Then we have degradation and conversion of critical habitats, seagrass, meadows, coastal wetlands, like what we have talked about before, and the role of groundwater in sustaining these habitats and coastal ecosystems. And then, of course, overfishing, alien species introduction for what's concerned biodiversity. So these four were the major transboundary concerns identified in 2005. All of these, some of these, not all of them, groundwater has nothing to do with fishing, but two key ones had relations with coastal aquifers. In fact, land-based pollution may be compounded by discharges of contaminated groundwater into the sea. As you know, groundwater, there are important outflows of groundwater into the marine environment all along the Mediterranean, and very important in some areas like the Adriatic, wherever there is karstic environments. And these waters might be polluted, and thus contributing to it because of industrial wastage, agricultural, and so on activities. The same happens with the coastal habitats. For example, overexploitation of coastal aquifers may induce salinization or marine intrusion, and hence degrade these coastal habitats and impact biodiversity, and so on and so forth. So you see, we are going to start with the main issues of transboundary concern identified in the 2005 TDA. We will be based on that, and we will try to identify and analyze with some detail, hopefully also geographically, going, in locations around the Mediterranean, the contributions of groundwater to these issues and the opportunities that might be in a better management of coastal groundwater to solve these problems. Continuing on this and to show you other major concerns are declining fishing, decline of seawater quality, human and health risks, and so on. And for each, we will go through the same process of making the link with coastal aquifers and see how they relate to this problem or might provide solutions to them. This is how we proceed. This work has not really started yet because we are in the process. This is our chronogram. As you can see, we are in April 2014, and we are having this introductory webinar. But the work on the TDA supplement has not started yet. It will start in June. Once all national reports and regional reports and pilot demonstration reports will be ready, because the TDA supplement can bring everything together. And so we need all of that to be completed. So we expect to start the work next June, and this work will continue. And we plan to complete it by the end of 2014. The process will be participatory in the sense that while there will be a group of experts, the national experts that have cooperated with UNESCO so far in each country, and headquarters of UNESCO will work on producing drafts of this supplement to the TDA. We will have 3 consultations planned. Consultation means this will be face-to-face meetings with all country representatives and experts and partners to analyze, review, discuss, consolidate, endorse the TDA drafts supplement, the supplement draft that will be submitted. And we hope to have the first one ready by September, and then take stock of the result of the consultation, prepare a second and final draft by November. Based on this, the work will continue on the sub-recommendation, on the recommendation for actions to mitigate the problems. And this will also include one consultation in early 2015, where we will present the proposals for action and discuss it with countries, experts, and partners. And finally, there will be needs for some time to finalize all these materials for presentation to MAP, to our client, and through MAP to the Conference of the Parties. So this is the process we're going to follow, and with the help of some of you who are listening to me this afternoon, because I see some of you are the one that cooperated in this on the pilot projects and so on and so forth. So I hope this will this short presentation has helped you in understanding a bit where you are, why you are doing it, and what is coming next. And of course, we are here to discuss, and hopefully there will be some reaction from your part. Thank you very much.
Thank you, Andrea, for that great introduction to the work that we have ahead of us this year. Raya now will take the floor and talk about the legal, institutional, and policy aspects.
Thank you, Matthew. Let me see if I can find my presentation. Thank you, Matthew. Good afternoon, everyone. Thank you for joining our webinar. I would like to thank also the panelists for accepting to spend some time with us this afternoon. So as Andrea just said, I will try to present to you the policy and legal aspects of all this topic on coastal aquifers. Okay. I will follow this outline for my presentation, so I will speak to you on the. Excuse me. We have some technical issues. Okay. Thank you, Matthew, for this setting. So I will follow this outline. I will give you an overview of the Barcelona Convention and related protocols. And I will give you an overview of the results of our activity on the legal aspects. So this is the situation in the participating country in this project. And I will give some conclusions, some, let's say, preliminary conclusions at this stage. So as you all know, as you're all aware, the MedPartnership project is working under the Barcelona Convention, which is the convention for the protection of the marine environmental and the coastal region of the Mediterranean. This is a new addition to the Barcelona Convention, which was amended in 1995 to add the coastal zones, not only in the Mediterranean Sea. Under the Barcelona Convention, there are 7 protocols, each one on a different issue. But here for us, for the topic of coastal aquifers, 3 of us are of concern. The first one is the one applied to land-based sources of pollution, the LBS protocol. Andrea just mentioned the importance of discharges in the sea causing pollution to the sea coming from coastal aquifers. The second concerned protocol for us is the SPA, Specially Protected Area and Biodiversity Protocol, because this protocol covers coastal wetlands. And finally, of course, we have the ICZM protocol, the Integrated Coastal Zone Management Protocol, because all our work is aiming to integrate the coastal aquifer into the management of the coastal zone. So what is the geographical coverage of the Barcelona Convention and its related protocol? The Barcelona Convention, when it was amended, covers now the Mediterranean Sea and the coastal area. So this geographical coverage applies for all the protocols and for all the work under the Barcelona Convention. Some protocols, such as the 2 ones I'm mentioning here, the LBS and the SPA Bio Protocol, have specific coverage, which is in addition to the general one of the Barcelona Convention. So you can see that the LBS protocol really covers our topic because it covers coastal waters, including groundwater, communicating with the sea. And the SPA Bio Protocol covers wetlands, and as it was mentioned by Matthew in the introduction, under our activity on coastal aquifers, we have a specific activity for the specific subcomponent for coastal wetlands depending on groundwater. The main principles, the main obligations under the Barcelona Convention are, of course, the main concern is to protect the marine environment, to protect the sea, and to protect the natural resources. So for implementing this general obligation, the Barcelona Convention introduces many environmental principles, such as the precautionary and the polluter pays principles. It introduces the obligation of an environmental impact assessment procedure, and it also introduces the integrated coastal zone management. This is why a few years later, the protocol on ICZM was drafted and adopted. Some specific obligations which will apply to our coastal aquifer derive also from the protocols. So the LBS protocol requires from the member states to take all appropriate measures to prevent and eliminate to the fullest possible extent the pollution of the Mediterranean Sea caused by discharges. So here we are really in the case of our coastal aquifers discharging pollution to the sea. The SPA and Bio Protocol requires from the parties to protect and preserve and manage specially protected area. So we can think here about special wetlands, which are protected areas and which are habitats for endangered species. And finally, the ICZM protocol aims to create a common framework for the integrated management of the Mediterranean coastal zone and strengthening regional cooperation among the countries of the Mediterranean. The ICZM protocol perhaps is the one that has the most principles that are of our concern for our coastal aquifer, because its focus is the coastal zone. So the ICZM protocol encourages the members, the parties, to apply the sustainable use and to manage the coastal zone in a sustainable way, to preserve natural resources and ecosystems, and specifically for coastal aquifers, the member states are obliged to monitor coastal aquifers and where the sea and the fresh water mix. And finally, it encourages participation of local population and stakeholders. So as you can see, all these protocols and the Barcelona Convention, as it is in the title of the aim at protecting the sea, but also the coastal zone. So the countries, when they became party, they have accepted these principles, and they should be applied, I would say, also to their coastal aquifers. So under our the UNESCO component on coastal aquifer, we had an activity on the legal aspect, and we had an assessment in the 11 of the countries. In each national report contained an assessment and a review of the water and of the water law and of the groundwater provisions in these water law or in any other legislation. It includes also an institutional analysis, which is an assessment of the institutions in charge of groundwater management. And we have identified, the national experts have identified what gaps, and they have provided some recommendations. All this information will be provided in a regional synthesis report, which is, I would say, work under progress. So what are the main findings? There is no surprise that our main finding is that there is no specific legislation for coastal aquifers and no specific consideration even for these aquifers in other instruments such as management plans or any other management tools. Usually coastal aquifers, they fall under water legislation, which is the case for all aquifers, for all groundwater. And this water legislation is more or less developed depending on the countries. But we have noted that the countries of Southeastern Europe have a more developed water legislation because of the strong influence of the EU Water Framework Directive. There are in some of the country-specific legislation in the form generally of a bylaw or specific provisions in the water law for groundwater. And there are also other pieces of legislation such as legislation related to the environment, which also applies to groundwater. What conclusion can we draw? This is the preliminary conclusion based on this national report. Coastal aquifers are specific compared to other aquifers because of their close relation with the sea. If you remember from this slide of the first presentation of Matthew, where he really showed the relationship between the fresh water and the sea for these aquifers. So they have, I would say, a dual ownership. They are coastal, so they belong to the coast, but they are also aquifers, so they have a specific management compared to surface water. So the coastal aquifers, they will fall under the water law because water laws usually include general principles applying to all sorts of water, applying to all sorts of water, surface waters or groundwater. They will also fall under a specific groundwater legislation when it exists or under specific groundwater provisions. But they have to fall also under any coastal zone management plans and strategies. And here is, I would say, perhaps the main, an important objective for us to reach. Of course, we don't forget that they will fall under other related pieces of legislation, such as the one related to environment or to protection zones when the coastal aquifer is part of a wetland or where it's part of a specific biodiversity area, etc. I think this is my last slide, and I would like to thank you for your attention.
All right, thank you, Raya. We have now some time allotted for discussion, and I wanted to let the attendees know that you're able to send us messages via chat, or you can pose your messages if you have a microphone connected to your computer. So I'm looking right now. There's also you have a chance next to your name in the list of attendees. You can raise your hand. There's an icon that will let you raise your hand if you want to ask a question. If you have a microphone, I can unmute your microphone in the system. So I'm looking at the list of chats right now. I don't see any messages. If you have some questions, please feel free to ask them now. We will have a discussion after the next point, the next 2 points. So there'll be some time again there and at the end. So if I don't see any questions now, we can keep a track of them. And if questions come up during the presentations on the pilot projects. So I don't see any questions coming in now. So perhaps we can move forward with the introduction to the pilot project, and then with the individual presentations by our colleagues that are working on these projects. So I'm going to pull up our presentation with the pilot projects. And I'm very grateful to Andrea for having made such a great introduction to the pilot project, because I don't need to give much more information. I just wanted to make the distinction between the pilot projects that are being undertaken entirely by UNESCO and those that are being complemented by UNESCO's expertise, but which are being led by our partners, POPRAC and GWP-Med. So the first set of pilot projects are those led by UNESCO, and we fall into 2 categories. The first one is looking, as Andrea said, at geochemistry as a tool for the management of coastal aquifers and helping us to understand how pollutants are moving between groundwater, lagoons, and the sea at a case study in Morocco. And then we have 3 case studies on vulnerability mapping. And I just wanted to explain briefly what vulnerability mapping is for those that may not be familiar with it. In general, it's a way to show the location and extent of a risk to a system. When this is applied to coastal aquifers, basically it allows us to understand how the geology of an area is providing a natural protection to the aquifer and the water below it. So we considered a number of case studies in Croatia and also one in Tunisia. And in the one in Tunisia, we have an interesting aspect in that we also considered the influence of saltwater intrusion in the model, in the map. So that's something that our colleagues will be discussing in a few minutes. Then we're very grateful that our partners, POPRAC and GWP-Med, will join us today to provide some more information about their pilot projects to which UNESCO contributed expertise and on groundwater and coastal aquifers. The first will be the transboundary management plan in the Bunubayana area shared between Albania and Montenegro. And then we will look at the work on ICCDM and coastal plans in Algeria. So with that, I will give the word to Viviana Ray. Viviana, I will give you the presenter privileges, and then I will activate your video. If you could just bear with me for a moment, please. Okay, Viviana, are you with us? Can you hear me?
Yeah, I can. Can you hear me?
Yes, we can hear you fine. Okay, all right. Please, the floor is yours, Viviana. Thank you.
Thank you. Where is the? Oh, let me just the presentation. Okay. So, good afternoon. I would like to put the video, but okay, it's here. I'm sorry. So, good afternoon, everyone. And today, I would like to show you some of the main results we obtained for the development of the pilot case study in Morocco. In particular, the area object of our investigation is located clearly in the northern shore of Morocco, close to the border with Algeria and the Spanish enclave of Melilla. The focus of our study is the Guard coastal aquifer and the nearby lagoon of Nador, which represents the main outflow of the groundwater flowing towards the sea. The area is characterized by semi-arid climate and the absence of a regular rain season. As concerns the production in the region or the economic activities, the main sector is agriculture, as you can see from the presence of those agricultural lots in here. As concerns the irrigation sources for agriculture, local farmers use both groundwater and the river water coming from this river here and distribute it through an irrigation channel which is bordering the rural plain. So the overall objective of this pilot case study are to support science-based management practices by providing data on water quality in the COSTAL Aquifer and the nearby lagoons Major, while the specific objectives are to assess the baseline condition of the system and to evaluate the human-induced deviation from those baselines, and clearly to assess the interaction between groundwater and lagoon water, also evaluating the quality of the groundwater which are discharging in the lagoon. So for doing that, we performed an hydrochemical investigation and we dealt with measure and trace element geochemistry. And in particular, we used isotope tracers to identify the water fingerprints and to discriminate among the different sources of pollution. The work has been partially financed by the Italian Ministry of Environment, Land and Sea and UNESCO-IHP, and benefits from the contribution by some colleagues from Italian University, Moroccan and Spanish ones. So briefly, the main results we obtained so far. The geochemical investigation allowed to confirm what was highlighted in previous studies, so that the main water type is sodium chloride, and the fact that the aquifer is characterized by very high salinity in general. Salinity is quite high. And our results show that this salinity is given by natural processes mainly related to water-rock interaction processes, but also to human-induced activities and mainly related to agricultural return flows. One other important result of the study is that most of the samples we collected over 2 years have a very high nitrate concentration, and this is both in the rural area and the urban side. Thanks to the isotope tracers, we studied the isotope of nitrates. We could discriminate among two different origins for nitrate origin, and mainly associated to synthetic fertilizers in the rural parts and manure and septic effluents in the urban area. And of course, we could highlight that the system in general has a very high vulnerability to contamination and strong dependency on seasonal variation. In fact, we can see here an example from the data obtained for June 2010, which is a period, June in general is a period where irrigation is higher. We can see that the contribution to the general salinity are compared related to the intrusion of saline water from the lagoon towards the aquifer is somehow negligible, while the higher contribution to the general salinity in presence of high irrigation rates are both lateral recharge from the main river flowing in the central part of the plain and, of course, agricultural flow, return flow. And if we compare these results with the one obtained for November, which is a period in which we have no or very low irrigation, we can see that the salinity is mainly given by water-rock interaction process and somehow mixing processes in the region. And you can clearly hear in this kind of distribution map, where we have high irrigation, most of the salinity or the chemical composition of the groundwater is really influenced by human-induced processes, and in absence of very limited irrigation, the salinity is mainly a natural one. So to conclude, or to summarize the main outcomes we had so far, our study highlighted that the system has a high salinity, which is due to both natural and human-induced processes, and we could also discriminate among the different sources of nitrate, the very high nitrate concentration. Also highlighting the very high aquifer vulnerability and its strong dependency on seasonal variation. Of course, this work has very important management implications. That is, on the one hand, there is a clear need to clarify some points, and that's why the investigation is still ongoing, because we have to better constrain the sources of pollution in order to provide sound recommendation. But clearly, a control of applied irrigation volumes and the identification of alternative irrigation sources could really help improving the water quality. and most importantly, I think, enhancing public participation and involvement of local farmer associations could help us imposing adequate groundwater protection. Thank you, and that's it for the moment. Thank you very much.
Thank you, Viviana, for that wonderful overview of your work. Maybe we'll have some more questions on it when we take questions a little bit later on. Right now, I would like to pass the floor to my colleague Ranko Biondic from the University of Zagreb, who undertook a vulnerability map at the Novoljanska Zrnovnica Carson Spring catchment area. Thank you for your patience with my pronunciation. Ranko, let me give you the presenter privileges and get your presentation up on the screen. Here we go, and I'll refresh this so everyone is looking at the same presentation. Okay, Ranko, can you hear me? And are you ready to take the floor? You have five minutes. Yes, we can hear you. Do you want me to turn your video on? Do you have a fast enough connection?
Okay.
Okay, there you are.
Okay, thank you. Hello, everybody. Good afternoon. I would like to show you one project which we done as an example of the vulnerability mapping. We choose Novljanska Zrnovnica, Carson Spring catchment area, which is in Croatia, and you will see why. For the beginning, maybe for the introduction, vulnerability or natural intrinsic vulnerability mapping can be used in spatial planning in assessment of impacts for the karst aquifers, determining the sanitary protection zones.
We're going to cut the video because we're having trouble hearing you, so maybe if we just have the microphone, we'll have a better connection with you. Do you mind if I cut the video?
Can you hear me?
We can hear you, but we're having trouble with the video, I think.
Oh, I don't know. I see. Okay. Can you see me now?
Yes, but I'm worried that the connection is not fast enough to support the video. But
I don't know. I don't know what to do.
Okay. All right. We'll continue, and we'll see if we can solve the problem.
Okay. Then for the determining of the sanitary protection zones, and for the active approach of the protection of aquifers, and also for the setting the priorities for the remediation in some catchment area if is needed. So we tried to implement 4 well-known methods of vulnerability in that project on one catchment area. That is the PI method, COP method, syntax method, and methodology of the COSTAL planted project from the 2004. So we tried to find some advantages, disadvantages of usage of those methods in karstic aquifers such as the Novljanska Zrnovnica catchment area, and using the experiences we tried to let's say propose new methods for the dynamic karst terrain, and that is KAVA method, karst aquifer vulnerability assessment.
I'm sorry, we're having a hard time hearing you.
You cannot hear me? Can you hear me?
Yes, but it's very. We can hear you, but
can you hear me now?
We're losing about every other word. All right, well, try to continue. And yes, we can hear you now. Yes.
Okay.
Yes.
Why we choose the Novljanska Zrnovnica spring? First, this spring. Sorry. Can you hear me?
Yes, now we can hear you. Please go on.
Novljanska Zrnovnica is one of the greatest coastal springs in the northern part of the Adriatic Sea, in the Croatian side of the Adriatic Sea, and is captured for the water supply of very touristic zone of Krenica and Novi Vinodolski, which is very important, and in the same time it's impossible to maybe some alternative sources for water supply in that area. Main aquifer is built of well-permeable carbonate rocks, and that is one of the greatest drainage system of the North Adriatic area. So it's a typical for dynamic karst. With surface flow, we have two big rivers, Gatska and Lika, which are swallowing into the underground. Then we have underground floor, groundwater depth up to the few hundred meters, and after that discharging on a very wide area in the coastal springs, which some of them are temporary, some of them are permanent, but most of them have a problem with the salinization. During the rain season, we have a lot of spring and a lot of rain, precipitation rate is very high, but during the dry season, discharge decreasing and let's say only Granovnica remains for usage in the water supply. In this area, we during the history we had a lot of tracing tests and a lot of hydrogeological data. So with those four methods, we did vulnerability maps, and you can see here very in brief just the final maps of that methods. The best method, the CAVA method, we try to propose based on four basic factors: overlay protection, precipitation influence, infiltration conditions, and aquifer conditions. And we try to implement tracing tests and results of the tracing tests into the vulnerability, one of the vulnerability methods. So you can see here the layers of that method: overlay protection layer, precipitation influences, infiltration conditions, and aquifer conditions. And finally, you can see the source and resource vulnerability map, which can be differed by the one factor which is connected to that tracing test, or let's say the dynamics of the groundwater flow. So by the first source vulnerability maps, we found that 18% of the area is of extreme vulnerability, 34% of the area of very high vulnerability, and that map can show the, let's say, the impact of some parts of the area of catchment to the quality of the water on the final spring. A resource vulnerability index shows the assessment of the vulnerability of the karst aquifer, and by the resource map, we found that only 7% of the area is of extreme vulnerability, 35% of very high, and that is a very important tool if we have to or we want to make some spatial planning in the catchment area. So as a conclusion, it can be seen that all the methods were tested on the example of the karst catchment area of Granovnica, which was selected as a typical catchment of the dynamic karst region. This new method is developed with goal to, in maybe more realistic way, present the intrinsic vulnerability of the karst aquifers of the dynamic type, and we believe that those methods will find its application in some other areas in the Mediterranean region. So detailed information about the method will be found at UNESCO, and they have the final report with all details. Thank you.
Thank you, Ranko, for that presentation and for your patience with the video feed. I have questions later, and maybe you can share with us how this map, how the work may help to inform some of your local decision makers about land use or water management in the area. Right now, I'd like to give the floor to another Croatian colleague, Mladen Kuta, who will talk about the vulnerability mapping exercise. He and his organization. Mladen, and you can turn on your control of the presentation now, Mladen. Can you hear me?
We are kind of losing you, Matthew.
Do you hear me?
Okay. Thank you, Andrea. Okay, Mladen, can you hear us?
Yes, I hear you. Do you hear me?
So let me turn on your video, and we will begin your presentation. And please remember, we just have 5 minutes for these, so please try to keep it as brief as possible. Thank you.
Yes, I will try. Let's just start my presentation. Please, can you start?
Here, okay, let's see. Here is your presentation. It should be on the screen now. Do you see?
No, I can see. I can see. It's still the last slide of the Ranko presentation.
Okay, let me get your presentation on the
Okay.
Yes, okay.
Now I see. Okay, let me start. First, good afternoon to everybody. I will.
Okay.
Okay. Okay.
Great.
I will try to briefly present the results of vulnerability mapping of the Pula coastal aquifer. That was done by syntax method and cross method. The Pula area is located on the southern part of Istria Peninsula. That is part of Dinaric karst area of Croatia. The main characteristics of the area is that
excuse me, I'm going to cut your video because we're I'm sorry to interrupt you. I'm going to cut your video because we're having a hard time seeing and hearing you. So I think maybe with just the microphone it will be clearer. Okay.
I don't know what's the problem. Do you hear me? Do you hear me?
No, yeah, we can hear you and see you, but I think it's too much. The video is too much. So, okay, go ahead, please, Mladen.
Okay. The main characteristic of the area concerned is that is characterized by low relief energy. It means we are talking about one karst plateau or karst plain with elevations ranging from 0 to 100 meters. That's the area, of course, of submediterranean climate type with mean annual air temperature of 14 degrees and mean annual precipitation range 8 to 900 millimeters. According to Coring land use map, you can see that the large part of the area are covered with arable land, forests, agricultural areas, pastures, and of course urban areas. The largest one, of course, is city of Pula. Few slides to take impression about the landscape of the area. I would like to note you can see the color of Terra Rossa display importance, which range from thinly bedded limestone with up to 50% of dolomite to thickly bedded massive limestones. And regarding to data obtained from data fieldwork on lithology, texture, structural tectonic characteristics, groundwater dynamics, We produced the hydrogeology map of the area and assumed or determined 4 categories of permeability in the area, range from low to very good. Later on, during activities, we try to prove that our assessment is correct, to see or maybe it isn't, by 2 tracing tests, but fortunately they confirm our estimations about the permeability of the rocks, because the thickly bed limestone get vulnerabilities. The velocities in range 5 to 7 centimeters per second, what is it, a very good permeability, and the maximum velocities for the thinly bed limestones vary about 1 centimeter per second. That indicate mentioned in the area soil cover, which is mainly consists of terra rossa. We did some investigations and drawings, and the reason was the granulometry, and it can be pointed out that the terra rossa regarding to the grain size can be classified as silty clay loam, silty clay, up to clean clay, depending actually of the depth. The content of clay increase with that. The second problem and the largest problem is irregularity of that cover, as you can see from those slides. On the field, during the field work, we try to divide the cover in 3 classes. Where we have outcrops, it means that the cover actually is scattered and very thin. It means the range 0 to 0.5 meters. If we have some fragments of the bedrock in the cover, it means bedrock should be closer, and the depth of the cover is 0.5 to 1 meter. And in the areas where you can't find any fragments in the cover, it means that the soil is thicker than 1 meter, and the actual real thickness can be found only by drilling. Here is our final soil cover map. Besides the granulometric analysis, we did some field investigation on permeability of the cover that pointed out that the terra rossa is of low permeability, which decreased with the depth. Here is set of syntax method parameter map that have been produced by the technique. During production of the final map, we used the proposed weight strings that are proposed by syntax method, the cars and partition media, and one which we created to adopt the criteria for the area. The results are here for weight string cars proposed by syntax, and you can see that more than 90% of the area belongs to the high and very high increasing vulnerability. By Fisher string, we get, let's say, similar results, but with the Pula string, which take into consideration positive effects of the cover more than in previous 2 strings, the high vulnerability can be 21% of the area. And according to the COP method, we get somewhat different results, but the results of syntax and COP can be compared directly. Because in syntax we have 6 categories, here we have 5, and according to our COP map, very high vulnerability covered about 36% of the area, medium about 33%. And the final conclusions actually are that vulnerability mapping is really useful tool, especially for the planners and decision makers that actually don't understand our hydrogeological and geological terms, when vulnerability mapping concludes a large number of specific or specialistic parameters and transfer them to easily understandable maps. According to our opinion, the better results we get by syntax method. COF method is more suitable for terrains with more express relief and differences in ecology. Both methods and all used tools confirm the positive impact of soil cover, but we should be careful in case of 1-2 meter deep cover. You should know that the sewage system, septic tanks actually are deeper. And finally, in principle, vulnerability assessment and especially conducted studies represent important contribution to better understanding of the geological and hydrogeological conditions and the studied area, and we hope it will contribute to better groundwater protection too. Okay, thank you.
Thank you so much for that. It's great you're sharing some of your lessons learned, so with other countries that are interested in undertaking a similar activity can learn from your work. All right, thank you. We're going to go now to the final vulnerability mapping case study. This was conducted in Tunisia at the Barcelona Coastal Aquifer, and to present will be our colleague Salvatore Taruba. Salvatore, let me just pull up your presentation, and then I will give you the floor. Just bear with me for a minute. I've given you the presenter privileges. We're getting some feedback in the background, Salvatore. Are you able to turn off? We're hearing an echo.
Sorry?
No, we're hearing an echo in the background of your on your computer. Do you have another device connected, or a cell phone, or something?
Can you hear me?
Yes, we can hear you, but we're hearing feedback. Okay. Let me turn on your. Okay. Okay. Try. Is it better now? No. Okay. Let me try. Let me turn off someone.
Balance should turn off its.
Okay. Yes. Okay. I think that's better now. Salvatore, are you with us now?
Yes. Can I speak?
Yes. Let me. Okay. Okay. Please go ahead, Salvatore.
Okay. Good afternoon, ladies and gentlemen. It's a pleasure and an honor to be here, to be able to share with you this study on the Barcelona Aquifer in Tunisia. The Barcelona Aquifer area is located in the north of Tunisia. The goal of this UNESCO-IHP project is to create a vulnerability map based on a single parameter that is called comprehensive vulnerability, able in describing simultaneously vertical vulnerability against the vertical pollution from surface and horizontal vulnerability due to saltwater intrusion phenomena from the east part of the aquifer. Simplifying the hydrogeological model, the main aquifer is of the area of Barcelona. The main aquifer is constituted by the grey Portofarina that are sands and calcareous, each other mixed. This aquifer is a multi-layer aquifer, and this aquifer is in direct connection with the younger deposits, permeable deposits, and the sea in this part of the aquifer. On the other hand, the marner rough are impermeable clay rocks and constitute the bed of the aquifer. In this picture, we can see here the calcareous of Portofarina, the great Portofarina, that are the aquifer, and here the younger deposits. While in this other picture, we can see the contact between the marner rock, that are the impermeable deposits, and the calcareous aquifer, main aquifer, or with the graded Pastosalina. So, keeping in mind that vulnerability is an intrinsic characteristic of the aquifer, independent itself from an external threat that can be a pollutant or a contaminant, we must look for the intrinsic characteristic of the aquifer that can be able in opposing to a pollutant from surface or to a contaminant like saltwater intrusion. The natural physical properties that an aquifer has of an aquifer that can protect it from a pollutant coming from surface, so we are speaking about vertical vulnerability, are deep to water, infiltration range, attenuation action, one separate zone, soil action capacity, aquifer types, hydraulic conductivity, slope, and other intrinsic characteristics. So, looking at this schema, we can of the area of Garden, we can see that all the large part of the aquifer has an elevated vertical vulnerability rate. In fact, we have a shallow aquifer, permeable deposits, permeable aquifer, and a permeable soil. Moreover, we have a gentle slope. So a pollutant coming from surface, it is an extent that can easily reach groundwater. In this other part of the aquifer, of the territory, we don't have a large exploitable aquifer, so vulnerability is, you understand that must be low. Using a map, we can see that all this part of the territory has an elevated vulnerability rate, and this green part has a low vulnerability rate. On the other hand, if we want to map horizontal vulnerability, keeping in mind the definition of vulnerability, we can look for the main defense that an aquifer has in opposing to saltwater intrusion. And this main defense is the aquifer specific energy that is linked to groundwater level. In fact, more fresh groundwater level is higher above sea level, and more able the aquifer will be in opposing saltwater intrusion, pushing out saltwater. So, keeping in mind that aquifer-specific energy is the main defense that an aquifer has in opposing sea saltwater intrusion, it's easy to understand that in this part of the aquifer, where groundwater level is about the same of sea level, aquifer is fully exposed to the threat and don't have any method of defense for pushing out saltwater in this area. So this area in this study was defined as an elevated vulnerability, with an elevated vulnerability rate. All the other the area of the aquifer where groundwater level is above sea level and the bottom of the aquifer is under sea level was defined as a high vulnerability grade because in this area it's probable that saltwater is under fresh water, but human activities can increase saltwater intrusion and mix salt and fresh water. In all these other parts of the aquifer, naturally it's improbable that saltwater can contaminate fresh water, but human activities can induce saltwater intrusion or soil salinization. So, keeping in mind this schema, for plotting a horizontal vulnerability map, first of all, we must draw this line, this brown line. That is the line where the bottom of the aquifer has 0 meters above sea level, the elevation of 0 meters above sea level. Moreover, we need to map this line, that is the where groundwater level is about 0 meters. It's about the same as sea level, or few up above sea level. And moreover, we need to draw the contour line, the limit of the aquifer. If we use a color scale, we see that all this part of the aquifer has an elevated vulnerability grade. All this part of the aquifer has a high vulnerability grade because it is in this situation. And all this yellow part is medium vulnerability grade, while the green part has very low vulnerability grade. Now we obtained two maps, vertical vulnerability map and horizontal vulnerability map. If we use for the two maps the same numeric scale, where 0 means very low vulnerability grade and 1 means low vulnerability grade, while red is, or 4 is elevated vulnerability grade, we can merge the two maps. Really, we can merge more than these two maps. We can merge, for example, the certification vulnerability map or other maps. And if we merge these two maps, we obtain one map that we call the comprehensive vulnerability map, that has only one parameter that describe with the numeric scale or a color scale the vulnerability map, the vulnerability of all the territory. It's simple to use because it is simply adding the vulnerability grade of each map, so that I am merging. So 1 plus 0 is 1, 4 plus 2 is 6, 4 plus 3 is 7, 4 plus 4 is 8. In this way, we obtained a map that is an integrated vulnerability map, because human activities data are also plotted. In fact, plotted the pollution sources, subject of contamination risk, and drainage network. Therefore, this map is a great instrument for territory planning and for safeguarding the environment and groundwater resources against pollution and overexploitation. It's important that we can analyze, we can represent all vulnerability of a territory with only one parameter, and it is easy to simple to use. The methodology developed for mapping the comprehensive vulnerability of this system is a new concept and could be replicated at other Mediterranean coastal aquifers. Thank you for your attention.
Thank you, Salvatore. All right, we're ready to move on to presentations from our colleagues that are working on integrated water resources management and ICCDM. So with that, I will pass the floor to my colleague Dimitris Paloutsos of GWP Med, who will talk about the Buna Bojana project shared between Mont and Albania. Dimitris,
hello, everybody.
Let me pull up your presentation before we.
Sure.
Okay. Let's see. Okay.
Well, hello, everybody. My name is Dimitris Paloutsos. I work for Global Water Partnership Mediterranean. For those that we have not met in the past, GWP Med is one of the institutions, along with UNESCO and UNEP that works for a pilot activity to implement a methodological framework that is being prepared by these institutions. And the pilot, one of the pilots, is in Buna Bojana. I use the arrows, right?
Yes, you should have control now of the presentation.
Okay, it doesn't work.
Okay, you could also try the arrow on the screen.
Okay. Some words a bit about the integrated methodological framework. There is the coastal zone management and the integrated river basin management, and there are arguments with regard to the surface waters and groundwaters, and there is an effort for conjunctive use for surface and groundwaters. With regard to the management approach, there are different starting points. In terms of ICSM, managers take into consideration mostly the land uses, while in the river basin management, the water uses are being taken into consideration. Of course, what us water managers could use as best practice in terms of how to conduct management is the land use. For example, river basin management, the land use should be taken into consideration, because when we talk about groundwater resources, which part of the water resource management, then land uses is of utmost importance. Although we're speaking about one system, which is the river basin system with the coastal zone, the management is being made separately. While trying to put together these management approaches and understand how to do it in a way that responds to the overall management of the system, one has to take into consideration, and this is one of the difficulties of the different institutions that are responsible for the different parts of the area. So although scientists may be able to understand the system and what are the pressures, then when we decide to discuss about measures and how these are implemented, then there are cases that you have to work you're against the wall, because there are overlapping competencies among different institutions. When speaking about integrated coastal basin management, one has in mind the obvious, which is that the upstream uses influence the downstream uses. This is always the case. For example, in the Buna case I will talk about, if, for example, a given country decides that tourism is of utmost importance for the development of the country, that immediately takes of specific management approaches upstream. For example, in Albania, where we have about 70% of the installed power capacity is hydropower produced in the basin, of which Buna basin is the most important. Explain where Buna basin is. Mediterranean. This is a dream basin. It's shared among several countries. It starts from. Can I have Matthew? Can I point into the?
Yes, at the top left of your screen, there's a blue arrow that you can use as a pointer. Do you see this?
This? Okay, yeah. So it starts here from Greece, groundwater resources, Drin basin. It receives water. Drin receives water also from Kosovo, and the combined flow ends here, which is the outflow of the Skadar Lake here. So now, sorry again, Matthew. I have drawn some lines here. Can I? Yes, I can raise them. Sorry about this. I'm sure it's my first time. Okay. So this is the area. This is the extended area, but this is not the Buna basin per se, because the Montenegrin government wanted us to look also in other parts of the coastal area. It has been, since there are minimum resources for that, there was kind of negotiation. Then we agreed that the coastal zone management plan will look at this extended area, while the integrated coastal and river basin management plan would look specifically at the Buna basin. There were two groups of experts from each one of both Albania and Montenegro working to provide information. This is a hydrological map of the overall study area. But as I said, the water component and the coastal zone management integration will be applied specifically in the Buna river basin. Speaking about the boundaries of the basin, this is easy to be found when we're speaking about surface waters and coastal zone. It's the basin, okay. But what about the sea? We need to take into consideration the sea and the groundwater. We'll discuss about this in a minute. So we need to see also the interaction between the marine environment and the coastal area. We took into consideration the bottom of the delta, of the two arms of the Boyana in the delta, Buna Boyana in the delta. Also, we took into consideration the salinity of the water in the marine area to understand what is the area of immediate effect from the surface freshwater coming from the combined flow of Drina, Buna, and scattered into the sea. So the management area should be the river basin, the coastal aquifers, plus, of course, the coastal zone, plus the marine area that's under the direct impact of the Buna. So when we're speaking about water resource management in this part of the world, there is a water framework directive, which although near Albania or Montenegro or parts of the European Union have voluntarily accepted to move forward as they have in their mind in the long term to become members of the European Union, they have accepted to incorporate in their framework the water framework directive. So we said, since we'll be doing this, let's kind of pioneer in the area, and for the first time in the area, implement the water framework directive, and also in this way have a methodology that can be used by the countries or used and improved for other parts of their basins, both in Montenegro and Albania. So the first step would be to identify the water bodies. 3 water bodies were identified, in this case the upper part of the Buna, the lower part of the Buna, plus one lake in pink here, and another one in, I'm sorry, maybe this one? No. I'm trying to point the pointer. I can't find the pointer. I'm sorry.
The pointer is the blue arrow at the top left of the slide.
Okay, now fine. So this is a lake, and this is a lagoon. So these are the two other bodies that will be found, and this is the lower part of the Buna, and this is the upper part of the Buna, plus the groundwater bodies, which here they are. There are some karst aquifers that's in the Albanian part, and this is in the Montenegrin part. But this is the case. The coastal aquifer is not a karstic one. By the way, I'm not a hydrogeologist myself. I don't know. I cannot go into details about the hydrogeological element of the study. Well, I don't know whether we are familiar with the implementation of the water framework directive, but it's like a cookbook. One should understand what are the reference values for the different elements in terms of pollution, for example, or in terms of the biology and the ecology of the basin, and then assess what is the status. And by assessing the status, being able later on to have specific environmental quality objectives that through the measures should be met later on. So that's what we did. We took a campaign, an analysis campaign in 6 sampling stations in the Buna Boyana. We undertook a chemical status assessment plus a biological quality assessment. Again, the Water Framework Directive is a cookbook. It refers a different kind of biological indicators that should be taken into consideration to do a biological quality assessment. Among others, macroinvertebrates, which are small insects that live in the bottom of the river, plus plankton or vegetation. But considering the means available, we have used the macroinvertebrates. Just that. There are different indices that are used in this regard. It's like, again, cookbook, different scores in terms one collects the sampling. The samples are being analyzed to see what is the diversity and the number of individuals under each species, and applies this and scores specific scores, and then one can have an assessment with regard to the biological status, which could be anywhere between very poor, very good. Now, this is
we're running a little short on time. Could you try to wrap up in the next minute?
Yeah, of course I can. Yeah. This is the classification. It doesn't look good. Also, this is the overall classification in terms of Water Framework Directive, combining the chemical status with the ecological status. So this is where we stand. The situation is not good. Later on, in order to be able to set these environmental indicators, quality indicators, we need to understand where the pressures come from and what the measures should be. Land use, this is one of the elements we use. We have prepared a water budget using historical data to understand what is the intensity of the pressures in terms of quantity, apart from quality, preparing vulnerability maps for the groundwater, understanding where the pollution comes from, and understanding the pollution load from different uses like urban waste, agricultural activities, and from livestock, which is the main three groups of economic activities in the area, and making an analysis to understand from which exactly what comes from which part of the basin in terms of municipality and communes, understand the pollution loads in each one of it. Using all the information, preparing risks maps, because we for the groundwater we weren't able. There are not historical data in terms of quality of the water in the aquifer. We have to use whatever we have available, and then by being able to understand what is the pressures, the status, the pressures, we need to move forward into measures. For this, we need to understand what is the management of the system. By understanding the protected areas, we understand what is being possible in being done, what is possible to be done in different areas. There's coastal zone management tools that we are going to use in order to evaluate the pressures till now and what can be done in the future. Among these, the spatial distribution of settlements in the coastal zone, or what is the decrease and increase of population in different parts of the basin, or using information like the artificialization of the coastline. Where we stand now, we have gone all the way down to understanding what are the pressures, and the next steps we have to prepare a draft management plan to go with it in the consultation and have the management plan eventually prepared by the end of September. Thank you.
Okay, thank you so much, Dimitris, for that. Now we're moving on to our next presentation, which is by our colleague Veronique Evers of PAPRAC, and she'll be discussing the coastal zone, the coastal management plan in Ragaya, and also the ICZM strategy for Algeria. So, Veronique, I'm going to pull up your presentation, and once I have that up, I will give you the privileges to control that. So I'm doing that right now, and I'm going to unmute your microphone so that we can hear you. Veronique, are you with us?
It's okay, can you hear me now?
Yes, we can hear you now, Veronique.
Okay.
Thank you for joining us.
Okay, so hello everybody. I'm here today on behalf of PAPRAC to speak about the two activities that are led by PAPRAC with the support of UNESCO. So I will first speak about the National Integrated Coastal Zone Management for Algeria, where ICZM stands for Integrated Coastal Zone Management, as Raya said a little bit before, and Ragaya's Coastal Plan. So first of all, we have the activity of the strategy for Algeria. One of the reasons PAPRAC started this activity is that it is said in the ICZM protocol that each party should strengthen or formulate an ICZM strategy. So Raya already spoke about the protocol, the contents that are related to the aquifers, but it is also stated that all elements relating to hydrological systems should be taken into account in an integrated manner. And in that way, the endowment of UNESCO was really relevant. As you see, the Algerian coastline is quite wide. It is actually covering more than 1,600 kilometers. It is divided in 3 regions and 14 wilayas and almost 150 communes, which can give you an idea about how challenging it was to involve all possible relevant stakeholders in the process. Here you have the 12 main issues that were identified at the very beginning of the activity, from which 9 were considered as sectorial and transversals. So UNESCO provided 2 experts for this activity, one on the thematic of the aquifers and the other one on the legal and institutional framework, which is a transversal issue. Related to the thematic of the aquifer, I'm not an aquifer expert. I saw in the list of participants that are experts in that team was so if you have any question, maybe you could ask him. But his report showed that there are 59 aquifers on the Algerian coastal zone, which are unevenly distributed. So there are very big differences in terms of availability of groundwater in most regions. The main tropic pressures that were identified by experts are urbanization, agriculture, tourism, and industry. Taking into account these issues and the other issues that were identified and analyzed by the rest of the experts together with the stakeholders, a draft strategy has been produced and is still in progress. The main contents from the documents are the recommendations for improving governance and allow a better integration and harmonization of multiple interests in the coastal zone, and identified priorities and ways to progress towards sustainable development of the coastal zone. Regaia's project is one of the first applications of the strategy at the local level. It is the second joint activity of PAPRAC with UNESCO. So here you have the card of the Wilaya of Algiers, which is in the center of the coastal zone. And here you have the perimeter of our study. It is covering 2 municipalities, the municipality of Regaia and Ferrawa. And you can see here that this is as well covering a marine part. The site of Regaia was chosen because of its representativity, because actually most of the issues you can find on Algerian coastal zone, you read them in Regaia as well. So you have here just some of the issues like illegal housing, dumping, industry, agriculture. It is also an area of high environmental sensibility. It is a Ramsar wetland, and it was used as a demonstration area for the application of the integrated methodological framework that Dimitris mentioned a little bit before. Here, I just wanted to show you shortly an output of this activity. It's a schema which is called the MOEBA. So in a few words, the experts, together with the stakeholders, identified 24 relevant indicators of sustainability for the area. Then they defined what value they could be given in the present situation and what would be a sustainable value for them. So in the green circle you see here, it is actually showing the limits where indicators are sustainable. In the yellow circle, it is the indicators that are not sustainable by excess, and in the gray circle, it's the indicators that are not sustainable by default. 2 of these indicators, namely number 13 and number 17, are directly linked with the aquifers because they are linked with the drinking irrigation and with the domestic consumption of water. And finally, these are the key achievements for the Coastal Plan for Regaia. So it was a multidisciplinary team work, ensuring a holistic integrated approach with the engagement of stakeholders through consultations and sustainability workgroups. And it allowed to have key inputs to the national strategy, including the inclusion of groundwater resource management. Thank you.
Thank you so much, Veronique, for that. I see that we're running a little bit late, so we had planned on presenting the information system, but I wonder if maybe we can take some time now for questions. So we've received a couple of comments during these past presentations. So perhaps I'll read these to the group, and then we can try to come up with some answers. Let me start here with there was a question about whether there would be a map of coastal aquifers with the type of pollutants and concentrations, and also at the same time showing the quality of the seawater. For the study right now, we didn't we gathered existing data. So as you know, a lot of this data was not available. So what we'll do, I think, we will be summarizing the data that we were able to collect, and that will be considered in the coastal aquifer supplement. There was also a comment about that the vulnerability mapping technique should be applied at all coastal aquifers. And the point of our pilot projects was just that, was to test some different methodologies so that for our next phase of the MedPartnership, we can propose these tools for our partners. Okay. So that's something that we will look forward to speaking more about. We'll have a regional meeting later this year on vulnerability mapping. So that will be a chance for us to be face to face to talk more about these studies, and also the tools that we can help provide to the countries so that they can we can, for a future phase of the work, undertake these vulnerability maps in other aquifers, because I think we're getting a lot of feedback from people saying this is quite a useful tool. So we look forward to engaging with the countries later in the year when that event is organized, and we'll be in touch with the colleagues soon about that. There was also a comment about seawater intrusion, and please be assured it will be addressed fully in the coastal aquifer supplement. It's a problem that was identified by many of the hydrogeologists in the activity on risk and uncertainty, and so it will be addressed in the future. But remember, this is the beginning of the activity. During the consultations that will happen later in the year, we'll have much more time to address each of these items in more detail. Maybe if Andrea has anything to add to that, we can give the floor to Andrea. Andrea, can you hear us?
Right. Can you hear me?
Yes, perfect.
No, and not much to add apart from we'll go through very quickly some conclusions, but I think we will have to analyze very carefully all the national reports and regional reports which are being finalized right now. We will extract most of the information there and come up with some conclusive documents, including maps. I think that since there is no time today to go through the web-based inventory, and maybe once that is fully ready, it would be a good idea to have another of these webinars just for that purpose, so that people become familiar and using it, and because that will be truly where the information will all be consolidated and available to everybody. Yeah.
Okay, thank you, Andrea, for that. I open the floor to other questions that may have arisen. If you'd like to send them to me as a chat, that probably is the easiest way for me to gather these questions. Or alternatively, you can raise your hand in the interface where next to your name in the list of attendees, you have the chance to raise your hand. Okay. I don't see any additional questions right now. So, Andrea, perhaps this is a chance for you to take the floor again and talk about the way forward and the conclusions. So let me get your presentation up on the screen, and I'll pass you the presenter privileges.
Very good. Thanks, Matthew, and really thanks to everybody, the presenters. That I think we all realized how broad, what a wealth of experience have been gained through these pilots and the studies that have been made. And I would like really to thank everybody for an outstanding job that has been done and for the very good presentations that we had this afternoon. Just a few words concluding. How we move ahead. Of course, we said we will produce this TBA supplement, recommendations for the SAP for actions to all countries, but we need truly to build some momentum through the experience gained with MedPartnership to move further and consolidate this integration of coastal aquifer issue in coastal management and marine protection. So this we will probably take opportunity of the last year in the last year of the project together with the MAP and the project management to see ways to promote these ideas and give it more visibility even beyond the Mediterranean. The other remark I would like to make, and is a kind of an experiment that is being made on the concept of coastal zone land and water resource use capability. This is a concept which has come from early environmental studies done in the US and other areas. And I think they contain a lot of interesting possibilities. For example, I mean, we have seen how important it is to have an assessment of the vulnerability of an aquifer, and also we have seen a proposal for a comprehensive vulnerability that provide us information also on marine vulnerability to marine intrusion. So that is great, of course. It's a fundamental piece of information for administrators. But I think that still needs some translation into more concrete indications. And that may be derived by introducing this concept of use capability. I made just a little test using the Garan-Mella comprehensive vulnerability map that has both horizontal and vertical vulnerability, and see how it would come out if we use the vulnerability map units, the geology, the land unit, and the vulnerability, and the uses that are being of the land and of the water that are being implemented in the region, in the area. The information derived from the report on the Garan-Mella. And so it nicely comes out that for each of the vulnerability areas, we can provide concrete indication on what can be done and what cannot be done, or what can be done with a series of precautions. I think this is something we should consider as and expand maybe as really the type of documentation that must be most useful for our land planners, administrators of the coastal area. And this is something we will probably have some more discussions next week in Athens, where we will meet on a IWLearn dialogue again on coastal aquifers of the Mediterranean, and we will meet face to face with many of you and keep on discussing this idea. But this is something I think we should consider as really how to translate all of our knowledge on aquifers, on the environment, ecosystems, biodiversity, and so on, into this type of land use capability. So this is an idea that I leave for you, and maybe we continue the discussion next week. And again, thanks really to all of you for a job well done. Thank you.
Great, thank you so much for that, Andrea. And I'd like to echo Andrea's gratitude to the other presenters. It was really valuable for us to have these brief overviews, and yet they provide us with the breadth of the work that's been undertaken, and it shows us the breadth of the work that we have ahead of us this year. So this is just getting into the dialogue. So if you have, if anyone has questions in the meantime, please contact us. We'll be in touch with you about upcoming UNESCO meetings, for example, the consultations and also the vulnerability mapping regional workshop that we'll be organizing later in the year. So just as a final comment, we will make the presentations available on the IWN website along with the recording of today's event. So I'll send that as soon as those documents are posted so that you can review those, and if you have questions later on, we can try to resolve those with you. So I'd like then to close the webinar. Thank again our participants, our panelists, for their participation and comments, and also just on a personal note, thank you for your patience with the technical issues. This is the first time that I've organized this kind of webinar, and I appreciate all of you working through with us through these technical challenges. So thank you again for your time, and we look forward to speaking with you soon. Okay, thanks so much. Have a good afternoon.
Thank you.
Thank you.